Hi, my name is Abigail,
And I'm Kurt Codina.
I'm Rodney.
And I'm Francis.
and we're Group D. Today, we're going to talk about the Android evolution. So, in the first part, we're going to present the different versions of Android. Next up will be their differences, and then their main characteristics and features. And we're also going to talk about what was added and removed. And lastly, the whole Android architecture. So, keep on watching.
In September of 2008, Google debuted Android 1.0 with the HTC Dream. It came with Google's most popular apps and also Amazon's MP3 store. It had an Android Market beta, and it only listed freeware, and widgets were already present back then. In April of 2009, Android released 1.5 Cupcake, and it was the first to be named after desserts. This version introduced the on-screen keyboard, the camcorder app, YouTube and Picasa video and photo upload, the Android calendar and music apps, Google Talk, and the auto-rotate and copy-paste function, and also third-party widgets. A short 5 months later, in September 2009, it was followed by Android 1.6 Donut. For the first time ever, multiple screen resolutions were available. The Android Market finished beta testing. The quick search box was introduced, which allowed users to search both the web and phone without leaving the home screen. The camera, camcorder, and gallery apps were integrated, battery usage statistics was added, and a power control widget for easy toggling of Wi-Fi, Bluetooth, GPS, sync, and brightness was added to the home screen. The following month in October in 2009 came Android 2.0 Eclair with the very popular Motorola Droid. Google Maps navigation was introduced, which brought free turn-by-turn navigation to smartphones. Support for multiple user accounts was added, with separate contact, email, and calendar sync settings for each account. The browser was updated with a hybrid search and address bar, and for the first time ever, HTML5. On-screen answer and hang-up buttons were added, so it allowed for phones to drop those physical keys. And the camera was updated with support for hardware, flash, photo settings, and saving to an SD card. In January of 2010, Eclair was updated to version 2.1 and released with the HTC Nexus One. It added the unprecedented Live Wallpapers feature for dynamic wallpapers. The app drawer now took over the entire screen. The gallery app was improved with larger icons and more intuitive user interface. The news and weather app debuts with a home screen widget. Google Voice was released, bringing a new way to make calls without a mobile carrier, and the pinch to zoom multi-touch gesture was also added. In May of 2010 came Android 2.2 Froyo. Android was already starting to gain significant market share back then, and in this version, under the hood, the Dalvik just-in-time compiler brought massive speed enhancements to Android. A Chrome browser API allowed push notifications to be synced from a desktop to a mobile phone. Apps could now be installed on the SD card. A native hotspot support was added. The V8 engine made the browser 2 to 5 times faster, and Adobe Flash support was added for a full desktop experience on mobile. And automatic app updates came to the Android store. In December of 2010, Android 2.3 Gingerbread was released. The on-screen keyboard introduced a suggestions feature, NFC support was added, Android Market 2.0 was released with a major redesign, and the Google Books app was added. In February of 2011, Android 3.0 Honeycomb was released. It was a tablet-only version, and it changed the design aesthetic that Google was heading towards to a darker theme. The status bar was moved to the bottom of the screen. The recent apps feature debuted, and it allowed for users to multitask by switching between apps directly. The action bar concept was introduced, and the widgets gained a lot more functionality. Android 4.0 Ice Cream Sandwich was released in October 2011, and it bridged the tablet and mobile versions of Android. All navigation buttons were now on screen. The home screen now allowed for folders to be made. Widgets were now resizable. Rejecting a call with a message was added. Notifications could now be dismissed with a swipe. An integrated spell checker was added. Data usage monitoring was added to settings. Music was now in the Play Store market. The Android store transitioned into the Google Play Store that we now know of today. Android 4.1 to 4.3 Jelly Bean was released between June 2012 and July 2013. The Google Now Intelligent Search Assistant was debuted. Notifications could now include more data, up to 8 lines of text. Google Play Services updates lessened the need for a full software update. Project Butter made animation smoother. The lock screen now allowed for widgets. Daydream interactive screensavers were added for use when charging or being docked. External display compatibility was added, and Bluetooth 4.0 low energy and OpenGLES 3.0 support was added.
Here we have KitKat, released in late 2013. The first version of OK Google support. The hands-free activation part worked only when your screen was already on and you were either at your home screen or inside the Google app. Here we have Lollipop, released in fall of 2014. Introduced a slew of new features into Android, including truly hands-free voice control via OK Google command, support for multiple users on phones, and priority mode for better notification management. And a UI core pattern that would guide the appearance of everything from notifications, which now showed up on a lock screen for at-a-glance access, to recent apps list. Here we have Marshmallow, released in 2015. Now on tap takes the concept of the smart assistant Google Now and spread it across the entire OS, which you can take advantage of it on any screen regardless of what you're doing. Which you can press simply home button, then Now on tap will analyze the information what you're looking for. Fingerprint scanning allows the scanners or any users to be used to not only unlock your device, but also use it authorized payments using Android Pay in the offline world or within Play Store apps. Here we have Nougat 7.0, released in August 22, 2016. Data Server is a handy feature you can use when running low on a monthly data allotment with your wireless plan. When enabled, Data Server will prevent apps from using cellular data in the background, which sometimes Twitter and Facebook may not refresh in the background very often. And it has feature where you can reply on the bottom of the alert and without no need to go to current screen. And here we have, instead of presenting multiple notifications from the same app as individual alerts, now the Android Nougat can now group them in a single line, so you can swipe down on a single notification to view more details and interact with each individual alert. Here we have 7.1. However, this is an upgraded version of the 7.0. What it has features here compared to previous one, as it has long press on app icons to reveal app specific action shortcuts, similar to what Apple does via 3D Touch, which is interesting that those actions can be moved to create new separate icons, and you can send GIFs directly from the keyboard without having a third-party GIF app. And then for split screen, you can use more than one app in a single screen. Just simply open one app that you want to use on your screen, then hold down the square shape overview at the bottom right to choose whatever app you want to show on your screen. Here we have Oreo 8, released in August 21, 2017. Picture-in-picture allows to watch videos in a small window form while using other applications. So you can have a conversation while watching a video. Small text selection in Android 8 is going to get smarter with a menu now showing suggestions relevant to the content highlight. So if you have a highlight, a phone number or address, you will automatically get an option to open phone app or Google Maps. 8.1 is just more of a maintenance release than a feature version. Pixel Visual Core, a first custom designed compressor dedicated to image processing. It improves the speed and power efficiency of shooting in HDR Plus mode. Android Go is a stripped down version of a full Android release designed specifically for devices with 512 megabytes to 1 gigabyte of memory. It's meant to boost the speed and reliability of entry-level devices, as well as provide the security and reliability that's often missing in low-end phones. Here we have Pi 9. Pi includes some noteworthy productive features such as universally suggested reply system for messaging notifications, a new dashboard of digital well-being control, and of course, there was no shortage of smaller but still significant advancements hidden throughout its filling, which includes a smarter way to handle Wi-Fi hotspots, a welcome twist to Android battery saver mode, and a variety of privacy and security enhancements. Here we have Android 10, released September last year. Has a totally reimagined interface for Android gestures, this time going away with tap-able back button altogether and relying on swipe-driven approach. And includes with system-wide dark theme and a new focus mode that lets you limit distractions from specific apps with a tap on a on-screen button and a long overdue overhaul of Android's sharing menu. Android 11, it's still in beta 2. It refines the system notification area to emphasize and simplify conversation-related alerts. It also introduced a new streamlined media player that contains control for all audio and video playing apps in the single space. Screen recorder can record device or internal audio and microphone at the same time. Bubbles is one of the Android 11's best feature, ability to have a conversation with on a bubble without going to a messenger app.
Android architecture. So, those are the items that are going to be in Android architecture. Let's get started. So, this is the structure of the architecture. At the bottommost layer, there's the kernel, or the Linux kernel, the hardware abstraction layer, the Android runtime, the native C, C++ language, the Java API, then there's the system applications. So let's first discuss the kernel. So this is the kernel. What is it? Well, basically it's the main operating system of the Android operating system. Yes, it runs in Linux. So a kernel is basically the heart or the core of an operating system. It manages CPU, the memory resources, and many processes on your computer. It also has built-in drivers in it, so anything from displaying to your screen or your Bluetooth or even opening files, that goes to the kernel, or that runs through the kernel rather. And it is the lowest layer of the architecture, which is the fundamentals or the foundation of the CPU. So next we're going to discuss hardware abstraction layer. The hardware abstraction layer separates concerns in the hardware itself, or the Android hardware architecture. It is a common technique used by a large-scale software development team in order to isolate key changes or complexities to certain layers, so that the top layer can be simplified and it doesn't have to be overwhelmed. So the HAL, or the HAL, typically helps in separating Android platform softwares from the hardware itself, because hardwares are always ever changing and always ever adapting and getting smaller, while the code itself doesn't need to change while we evolve to the hardware. Well, basically the key goal of the HAL is so that apps won't break while hardwares are changing. Well, second, it separates Android framework layers from the OS layers. For example, this layer can be programmed in Java objects or can be called in Java objects rather than C system function calls. Then the next one is ART, or the Android Runtime Environment, or the Android Runtime. It is written to run multiple virtual machines on low memory devices by executing DEX files, a bytecode format designed especially for Android to optimize a minimal memory footprint. Some major features of the ART includes the following: ahead of time and just-in-time compilations. There's also the optimized garbage collection, or the GC, and better debugging support. and many more. The Android The ART or the Android also includes a set of core runtime libraries that provide most of the functionalities of Java programming language, including some Java 8 language features that the Java API that's up top works on.
Let's move on to the native C or C++ libraries. So if we go back and look at the Android architecture, we can see that these native libraries work at the same level in the software stack as the Android runtime. But they're expandable, meaning device makers could add their own libraries to this layer. So if we examine this component, it includes libraries such as the ones displayed on your screen to manage all sorts of features of Android, including graphics, databases, encryption, and so on. Let's take OpenGLES for example. This is also known as Open Graphics Library. This library serves as a support for high-performance 2D and 3D graphics for Android. The Android platform also provides Java API framework. This exposes the functionality of some of these native libraries to apps. So if you're wondering what API is, it stands for Application Programming Interface. It is basically a software that enables two applications to talk to each other. So let's take our previous example again. You can access OpenGLES through the Android Java framework called OpenGL API. That will then enable the specific support a library intends to. That is one function of this framework. But this layer also has modules for controlling all the components of your apps, including activities, which represent the screens the user sees, content providers, to manage the data and move the data between apps, locations, packages, notifications, and so on. Finally, we have the system apps. Each version of Android has been delivered with an expanded set of included apps. But at minimum, every version of Android has a home screen, a browser, contact management, phone management, and a few other things. On screen, you can see some other apps that are usually built in as well. So more and more apps are getting included with each new version of Android. But you can add as many apps as you want to this layer, both coming from the App Store and apps that you may build yourself. So quick recap. Looking at the whole Android architecture, the system apps are the ones we see and interact with first, given life or bridged by the Java API framework, and supported by the native libraries.
While the Android runtime translates the bytecode into a native instruction, which is later executed by the device's native environment or native runtime environment, while the HAL or the hardware abstraction layer distributes workload and ensures integrity for the software, while the Linux kernel processes everything and handles the devices or the drivers and the processing. So once again, this is Group D reporting on the evolution of Android.